Hey, what's going on, guys? Let's look at these problems right here. The first question is asking for the following cash flows: receipt of 10,000 at t is equal to 0, payment of 50,000 at t is equal to 1, receipt of 50,000 at t is equal to 3, and receipt of 30,000 at t is equal to 5. Various interest rates are applied: 4% for year 1 and 6% for year 2 and 3, 5% for year 4 and 5. Find the equivalent net value of at t5. And here they're asking for f5. That's what we are trying to find. Now here we have three cases. At t is equal to 0 we have 10,000. At t is equal to 1, actually 4 cases. T is equal to 1, 50,000, and t is equal to 3, 50,000, and when t is equal to 5 we have 30,000. So we have to look at all these cases individually. Now let's look at the first one. Let's say f5. Initially we have 10,000, so I put that one right here. 10,000 times FP 4% year 1. This is called compound amount factor, and if you are already in this question, you already know there's a table to look at these values. So you have to look at the compound amount factor at 4% 1 year, and also this is for the first one. And for the second one, 6% year 2 and 3. It means 2 years are there, year 2 and 3. So 2 years are there. So this is going to be FP 6% 2. And if you look at the third one, 5% year 4 and 5. Here also 2 years, year 4 and 5. So 2 years. FP, and the interest rate is 5% and 2 years. And if you look at these values in the table, you will see for the first one 1.04, for the second one you will see 1.1236, and for the third one you will see 1.1025, and when you calculate this one you will get 12,883.20, and that's going to be the amount for A5 if you look at this condition: receipt of 10,000 at t is equal to 0. Now at t is equal to 1 we have another one, that's 50,000. So let's go ahead and calculate this one, FB5. So when t is equal to 1 mean we had to neglect the first one, and these two are considered. Okay, so we have 50,000 right here, and that is payment of, this is payment, so this is negative. If it's receipt, that's positive. If it's payment, that's negative. So negative 50,000 compound amount factor for 6%. I'm just looking at this 6% year 2 and 3, so 2 years, and 5% for year 4 and 5. That is FP 5%, and this also 2 years. And if you look at the values in the table, it's already there. I already written these two values, so that's going to be the same thing here: 1.1236, 1.1025, and when you calculate you will end up with negative 61,938.45. And the third one, FC5. FC5, here we have 30,000. Actually, no, second one is 50,000, and we have receipt of payment of 50,000 and receipt of 50,000. Receipt of this 50,000 means that's positive. 50,000. In this case, what we do, we just put this third one, 5% for year 4. So 5% for year 4 and 5. So this is gonna be FP 5% year 4 and 5, 2 years. And if you look at the value for that 50,000, if you look at the value for that, that is 1.1025, and when you calculate this value you are going to get 55,125. And that's it for this one. And FD5 is 30,000 at t is equal to 5. and we don't have anything else left, so this just 30,000. And F5 is basically addition of all these things. The first one is 12,883.20 plus, actually minus 61,938.45 plus 55,125 plus 30,000. That is equivalent to 36,069.75. So F5 is equivalent to 36,069.75, and that's the answer for that one. Now let's look at the problem number 2. Problem number 2 says you want 25,000 for 4 years from now for a new car, and your grandparents offer to give you 10,000 now. A part-time job will allow you to make 4 additional deposits, one at the end of each year. If the bank pays 5% interest, how large must be your annual deposit be? Now here's the formula. So we want 25,000, and initially we have 10,000 provided, and compound amount factor, and this is 5 banks pays us 5,000, so 0.05 in decimal, and this is each year 4 additional deposit, one at the end of each year, so we have 4. And if you look at the values, this value in the table, you will see, let's rearrange this one, $25,000 minus $10,000, and if you look at the value in the table, you will see 1.2155, and that's equivalent to $12,845. Okay, now let's look at another formula, that is A is equal to F prime. AF is sinking fund factor, that is this one AF, and 5% for F prime is what we calculated. This is, let's put F prime right here. F prime is what we calculate right here, that is 12,845 multiplied by okay, here sinking factor is this. Okay, I already put it right here. A over F, AF 5% for, if you look at the value in the table, you will see that is 0.23201, and if you calculate this one, you're going to get 2980.17. so we had to deposit 2,980.17 at the end of each year for 4 years combined with the growth from the 10,000 received. So we will have 25,000 at the end of the 4 year. So this is the one we have to deposit each year. Okay, now let's look at the problem 3. The problem 3 asks us, a French software genius had been offered 15,000 euro per year for next 4 years, and then 25,000 per year for the following 15 years for the rights to his new smartphone app at 5% interest. How much is this offer worth today? Okay, let's calculate that one. P is equal to 50,000. It had been offered 50,000 per year, so 15,000 PA 5% for 4 years. This is called series worth present factor, and plus 25,000 5% for 15 years, and also PF 5% 4 year. And if you calculate these values, this is going to be 15,000, 3.5460 plus 25,000, 10.380 times 0.82270. And if you calculate these values, you are going to get 53,190 plus 213, 490.65. And when you calculate this value, you're going to get 266, 680.65. So finally, we can say the present worth is euro 266.280.65, and this is the answer for this question. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn engineering economics, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.